welcome to Berserker Strength Radio's studios. You can see we use it for a lot of things here. We are going to be doing a series of seminars online having to do with electrical signature analysis and current signature analysis. The first one is going to be specific to the technology that we provide, which is the Framatome EMPATH electrical signature analyzer. Following this seminar, the one on Friday and the ones next week will not be specific to any one data collector. One of the nice things about today is the software we're going to discuss is virtually the same as the at-pole software as well. So those of you who are using all test equipment, you're going to basically see the same thing. Hoping the sound comes through all right on this because I'm doing it off the camera right now. In a few minutes, we're going to switch everything over. This is the setup. We're going to test this motor today. This is the EMPATH box. Right now, I have it set up to plug into the EMPATH E-plug, which is about an inch and a half, and 5/8 inch thick. So it's much smaller than other things you see on the market. The EMPATH system, this is the data collector, can also be used as a continuous monitoring device, which is a separate device that we'll discuss later. So uses the same software. What comes with this is 1,000 amp clamps. These guys here, 200 amp clamps. These here, they actually have two settings. Little secret, always use the 10 millivolt per amp setting. When I've tried using the other one to get the lower current reading, in order to take, say, data off the back of a multi-lin, I will find that it usually knocks out some of the signals I'm looking at. The 10 meter leads come with it. I've always wondered why on earth we send 10 meter leads with it until I had to do a DC motor at a steel mill, and the fields were roughly 20 odd feet away. So we were able to do that. I tend to just use some fluke leads. Actually, those are at-pole leads for my stuff. So just quickly wanted to cover that. You'll hear this running when we do the data collection. I'm only going to turn the drive on and off to do that because it's relatively loud in this space. Key things are on the front. You're going to see that there's 5 BN connectors. This one for the data collector, each one of these is a channel. So I've got 5 channels for inputs, 3 current, 2 whatever I want. So like for instance, when I'm doing wind work, we are going to be adding some additional channels of data collection for the rotor. But we'll discuss that in the super secret wind one we'll do next week. Below that, you'll see voltage inputs. On the EMCS, or the EMPATH data collection system, continuous monitoring device, each channel is one complete motor, 3 voltage, 3 current. So that's the difference. So from there, I am going to go over here and we're going to fool around a little bit because you never do this live. And pardon the scan rate, it'll change here in a second. You don't do what I'm doing right now. Everything's real time, unscripted. So we can have some fun because it's those times. So first thing is we are switching over to this audio. We are turning off the webcam and we are going to activate my desktop. Okay, I'm assuming everybody can hear me. I've got somebody elsewhere because we are doing this separation thing, so I am running all the controls as well. Let's go ahead and we're going to open up the EMPATH Framatome software. You also see the ECMS below it. This software is used for both the ECMS and the EMPATH data collection. Now, the ECMS is a separate module that's added in. I have it turned off right now, but this little nuclear thing here all the way to the left, assuming you can see it on the screen, but all the way here to the left, that would turn on that method. and I would be able to do continuous monitoring of a system, and it will perform a lot of the analysis. We're not covering that in detail today, but let's just say it's kind of nice because my data, my continuous monitoring and my data collection data goes into the same database. First thing too is you'll see down the side on the left-hand side here, it's a Windows-based system. It uses Windows folders. So be perfectly blunt, I don't, it doesn't matter where I put it. I could put it up in the cloud. I could have it on my PC. Normally when I'm in the field, I'll do it on my PC so I don't run into any trouble. So let's start on here. So just this today is a tour, so that if you're on Friday, when we cover how to analyze a pump, you will see the same software, but I'm not going to be spending a lot of time describing it. So let's go ahead and take a quick look. Up here, this main screen here, this is the data. This is an actual fan that I took earlier in the week. I've moved it over into this area. Let's just say all of the data I've taken since the late 90s till now is located on this laptop. The average data size is under a couple of meg. So if I come up here, first thing, let's take a look at our setup options. And this is how you set it up. So you want to put in a calibration number for the thing. You can put in either British, English measurements, or you can do it in, say, if you're doing a lot of IEC motors and you put it in SI, it'll show kilowatts instead of horsepower, that kind of thing. Also on here, there's a lot of checks. You can see which ones I like. Display hints too is also nice. And you can see as I scroll around, I've got little reminders of what's going on. That's because I've clicked all of these. On the right-hand side, you're going to see something. So for instance, if I'm sitting down and I'm doing a site, I'll just mention a wind site again because I'll go in, I'm going to basically be doing upwards of anywhere from 20 to 120 exact same towers. So I will set up the screens exactly the way I want them and then hit save. Like right now, if I click on here, it's based upon the last batch that I was working through. Default layout is what you'll see today. The as left, if you click that and you're working on something and you want to do the same thing with the next one, it leaves all the screens the same. So that's basically that part. Acquisition, this basically tells me, is it, basically it's a basic setup. This one here, I can select most block sizes. This is what the FFT looks at, the lines per inch. Most systems will be down in this range, about 16 or 15.6. I like 65.5 because then I can see details. So when I'm in slow speed machines, like in an elevator, I can look at individual components and individual parts of, say, a bearing or a gear, and also separate them from each other. The analysis section, again, this should show the same. I can do so many averages. I basically leave all these checked. And then here's the analysis section. So the first one, I want to have all these checked. This one here, it says allow positive calls due to the matching voltage peaks. So if I click on this, then what it does the opposite, really. What it does is it will not call something if there's also a voltage peak. Don't know why, because there's usually a sympathetic peak there. So I usually leave that unchecked because I'd rather be hunting for false positives than have false negatives when the software does the analysis for me. You'll see also down here, I can do a couple other things. With the settings you see here, these are the settings I found optimal for the variety of work I do in the field. The second one allows me to change colors for different channels.
This makes it easier, especially when I start layering data on top of each other. So for instance, if I open up one set of data and I want to compare it to that machine or another machine or a base machine, I can have that set up, and then I can change the colors so that they don't, so that they clash basically, and they don't show the same color and kind of blend in. Display extras allows me to look at the torque, the air gap torque of the machine, if I do voltage and current, all three phases. And then there's a bunch of other options in here that allow me to do different things. Normally for my use, I leave these all checked. Big one, this one I asked the programmer to do, and he thankfully did it. It allows me to come in and set all of my minimum. So because of the resolution of the EMPATH system, you'll see here it says minimum load to make a rotor bar call. I set it at 5%. The default is 25%. 5% means it's not loaded. So if I go into a repair shop and the motor's sitting there running on the floor cross the line full voltage, yes, the resolution of this system will distinguish the peaks. There's been some controversy because some of the other systems available do not allow you to do that. They wait until you have at least 50% load. That's never been the case with the EMPATH system. The EMPATH system is the original system based upon the Oak Ridge National Labs work into this for the nuclear power industry. So I can put that in there. I can set all my things. You'll notice down here things like belt slip. So it will make a call with belt slip. The default is 3%. I like to look at 2%, so it tells me that there's a belt slip issue. So I analyze that software closely, or that set of data closely. And then other things in here that I can go after. That's that. So once I have that done, and once I've set all that, and that's done once, you don't do it every time. You can go in there. There's certain jobs I'll go into and I'll change some of those based upon what I want to do, but it allows me a lot of flexibility. Next button will be this one right here. It says MS Access Database. This is so that I can do some trending offline. So I can dump in some data. I can dump in multiple sets of data. I can dump in everything from a folder or a set of folders, and then I can do some trending of some basic stuff. If I want to find out if I'm having a problem, it allows me to do that. So there we go. Basically, really straightforward, simple stuff. Okay, so that allows me to do that. This allows me to empty the database. So I can bring in data from a different location. This would say, build a database from the current directory. Okay, so in there I have a whole 2 sets of data. Ooh. Okay, so it will allow me to look at different things with those records. It will then, I can also do whatever else I need to do. So there we go. That's it. Now, big one. We have that motor over there, so I'm going to go ahead and set this up, and then we'll take a look at the data collection screen, and we'll collect data on this, and then we'll take a look at the rest of it. So, or actually, let's go ahead and touch on this one first. So if I come in here, you notice these 2 faces light up. Now, these buttons are kind of cute and everything, so this one shuts it down. But as we go through each of the pages, we'll notice that the headers, change a little bit. So this one here allows me to go in and put in all of my information. So I can select the type of equipment I'm testing. This is important because it changes the algorithms that are used to analyze different faults. So an induction motor, I also use for wound rotor motors. Synchronous motors I use a lot, including the 4,500 horsepower 13.8 machines that I test fairly often. VFDs, we're going to talk about that a little bit down the road. There is a way to use this technology to see if I have properly tuned the drive or not. Transformer allows me to take a look at the condition of a transformer. Generator, of course, is a standard generator. DC equipment, DC motors, it will also detect problems in the drive for the DC machines. Asynchronous generators, we now have that set up to cover most asynchronous generators, including wind turbines. So that's built in. Here we have everything, including driven equipment, because it will detect faults in driven equipment, including if there's belt slip issues. I then can detect, put in what I want to collect as far as data. Good news is if I go in and I've set this up for current and voltage and I discover it's safer just to take one phase of current, I can do that, doesn't matter. And then there's other things down here. You can see wound motor, slip ring motor, look for rotor bars and stator slots automatically, whether or not it's reciprocating equipment. Then the nameplate information, anytime you see a -1, it's going to hunt for that data. This one here is just motor enclosure, that's more for notes. This one will help me determine whether or not, what the efficiency is, what the line frequency is. This down here in the lower right actually has to do with continuous monitoring. Another thing is when I come through here, for those of you who've used electrical and current signature before, you know that rotor bars and stator slots is extremely important. We have an extremely large database with over 8,400 machines of virtually all sizes to work from. When I get into the pump testing later this week, we will go into how to determine what your rotor bars and stator slots are from this, as well as if you need to use auto detect. CT and PT ratios are there, of course. Don't need that while we're doing what we're doing today. Bearing information, yes, it will take the first two, plus if you have a direct drive system, you can enter in data here and here for the other bearings. The bearing database is massive with over 60,000 databases from a large number of manufacturers in here. So it's pretty intensive. So let's say if I'm just going to duplicate one of these bearings. Let's say I wanted to put in a 6322 here as well. I can either pull down the list or I can pop that in there and I can call this whatever I want to call it. Done. Okay, so have that, and then the next one, test info. This is all just for the report. Plan information just for the report. This is for the ECMS only. So you won't see this in a regular data collection system. Down here, this allows me to go in and update the database. So this motor database here, if I put in a new machine, I click on that, it will update it based upon the information I put in. So I can keep a database of the same motor. The other thing I can do here is if I have multiple machines that are identical, I can highlight this, copy it, and then go into another folder and paste it. And then I can collect the data right from that. So when I'm doing that, it's pretty straightforward. If I don't want it there, just get rid of it. Okay, so that's the basics there. Let's go ahead and just build a motor. So we're going to say new, and it's this motor over here. We'll call it the MotorDoc motor because it's brand new. I have not taken data on it. My buddies at TSA managed to destroy the other motor that was on this demo kit. That's the third drive. We're not going to get into that. So here we go. I have this here, and let's say it is a 0.5 horsepower motor. So I type that in there, click OK. There I go. I've got this. You notice this stuff up here is up. I come in here, and I can put this in. The nice thing is it has some default data in there. If I wish, I could be testing a 10,000 horsepower motor and leave it exactly like this. Doesn't matter. I can go ahead and do whatever I need to do. So it's a VFD grade motor. Let's see, we have 0.5 horsepower. It is a 1700. That's weird. 1700 RPM, 460 volt, 1.8 amp, and so we're going to over amp it. No load current, we're going to just say 0.1, just so I don't have any problems. I already checked on the rotor bars and stator slots. This one's not in the database. So I have 30 rotor bars and 24 stator slots. You don't have to worry about the rest of it. I can put numbers in here if I want. If I put in some other number, like 0 or something like that here, it's incorporated into the torque reading. So I usually leave that. It is a fan motor, and obviously with that efficiency, we'll call it standard. The bearing information, we'll put those in there. Because I don't know the manufacturer, let's go ahead and we'll just SKF, and those guys usually have about the right ones. And I think these are both 6203s. Nope, that's going to be a 6205 or 6304 on front. And this one is going to be the delay is my laptop. This one here is going to be a 6203. That's right, back one's 6203. There we go. We are all set. I now have everything I want to put in there, and I have now set that up. Highlight it. I also want to do one more thing here. I want to make sure that I have everything set on here. So I want to make sure I'm taking voltage and current, all 3 phases. That will display there. And we're all set up. So I'm going to go ahead and open this up. That's noise right now. And this is my data collection screen. So here's what I'm about to do. Most of what is up here in English, I also have here. So this is the data header. This, make sure everything's there. You notice amplification, that is done with gains, and there's a way of doing gains if I don't see what I want to see. This here, don't worry about that, single or all. I can manipulate one or the other. This one here changes the scan speed, so I can make it do different things. This allows me to zoom in. This will allow me to select what kind of channels I'm dealing with on this case. And this is my scan rate. So I'm taking 12,000 samples per second. This changes my data card resolution. I don't care. I want max resolution. This guy here allows me to actually look at the spectrum instead of what's here. And I'll show you that when we get there. This allows me to set a trigger level. So I can have it collect data by selecting, say, trigger. And we're going to go ahead and do that. Let's just say we'll trigger it so it happens there. And then this sets a couple of things. One, I can, in normal times, I can set the trigger time. But I am going to go ahead and just say, for our purposes, we'll just collect, we'll keep it at the default. Now it's just waiting for that trigger to occur. So this will allow me to get inrush data and the like. So let's go ahead and start it up, and we're going to do both things. So I've got it started now, and as soon as it passes that threshold, you can see it's collecting data. And wow, is it collecting data? Look at that. Unloaded, sitting on my bench, 1.8 amps, it's drawing that. So you'll notice down here in the lower left, there's a % complete. So as it goes up, we're at 67, 68, 69, 70% complete. That's how long it's taking to collect data. And it's going to save it into that folder. I don't have to worry about anything. And if I decide it's taking too long or it shuts down or something, I can tell it to stop. Okay, and it stopped. There we go. So there we are. There's the data it's collected so far in this one. Now, if I want to grab data again, so this is what we're looking at now, that running, okay? I can go through whatever I need to go through. If I don't feel that it's showing me what I want it to show me, I can hit gains and it'll go through and adjust the gains. If I've got a waveform like this, I usually won't mess with it. I can set the download length to whatever I want and then just hit download. So as you can see again, here's my percentage complete in the corner. So this is now just showing me all three phases, and I just let it go, and it's going to take less than a minute, and then we're going to go into the analysis portion. This is pretty straightforward stuff. It is nice, you can watch it real time. So as this stops, I'm going to turn off this little motor here. Okay, so let's get rid of you. Let's take a look at what we got. So you notice it popped up an analysis screen. I'm running no load, so it's trying to pick something out here. I don't have anything here. The old motor I had actually had a casting void issue, showed up nicely, but of course this one isn't. So here we are in the analysis part. First thing that happens when I'm done collecting is it pops this up and it'll give me what it thinks. I can do a couple of things. I can ask it to take a look and verify the running speed and the pole pass frequency on its own. So here we are, and this does not look like a pole pass frequency. Let's go ahead and say, well, it selected a running speed here on the right-hand side. You can see this is my DMOD. This is what I use it for. Don't actually use DMOD for troubleshooting anything. If I highlight it, it tells me that I'm at 881 RPM. Yep, that would be about right. So there we go. It's adjusted for my about 30 hertz. And the pole pass frequency might be somewhere else, but I think that's fine now. I don't see anything on either side that would be an indicator of a pole pass issue. So this is my low frequency spectrum, higher resolution. And if we come across the top, this closes. This allows me to take a look at that header again. This allows me to look at the different channels, as I said, so I can look at all of my different voltages and all my currents. And it also tells me what's what up here. This allows me to do the same thing as the other one. I can manipulate one screen or multiple. This allows me to zoom in. So if I wanted to say get in close, I click on that. Or I left click and drag across, and then I click on that. And there we go. This brings me back. It actually steps me back. The Y allows me to zoom in the vertical axis. So if I'm just interested in just this peak here on the left, and I want to keep that there, there we go. And if I want to do both, I click on the auto scale. Okay, so let's go back here. These are different buttons that allow me to display different things on the right-hand side. This allows me to insert additional labels. This will print just these screens. This will allow me to look at the waterfall plot of whatever screen I've highlighted. So I can do an analysis, and it will also allow me to come in and zoom in on whatever part I'm interested in. So, so this is my dB amplitude. This is my frequency, and this is time, is the z-axis. This allows me to do some analysis up front here. And this one here is what we're looking at, shows like a calculator. Okay, and I can go in and take a look at all my different stuff. So like this here, tracking, this is what I trend with. Phasers, this is my harmonics. So there's my voltage harmonics, my current harmonics. This is what my bearings look like. This is what it all calculated as far as my line current, running speeds, and so on. This gives me what it thinks the efficiency is and the load. I can switch everything over to horsepower if I want. And then my results. From here, I've got that ability to rescan everything. The MS Word report allows me to run a report. And then, of course, this allows me to populate the database. I'm going to do the report right now because it takes a minute or two for it to run. We'll come back to that after we do everything else. The other thing I can do is come in here, and if I think I have bearing damage, I can highlight this. It'll identify where the peaks are in my linear scale down here, DMOD. I can also do things like up here, start working with my different types of filters, and I can even change the minimum dB level. If I think that the noise floor drops below here, I might set it down, say to -120. I can change frequency to RPM, especially if you happen to be a vibration analyst and you're used to working with that. You can do that. I can also switch it over to linear so it shows in true current each of those frequencies. Okay, so that means that you know, like there's my line frequency and there's the actual frequencies. Now I do it in dB, which is the log or the log 20 spectrum of current, or log 10, what is it, twice log 10 of the current. So that's there. So let's go ahead and switch this back out. I like to use relative. Now the other one I get to do, and this is for my analysis of the rest of the systems, let's come up into my high frequency spectra. Let's get this into everything that happens in here on my FFT, or fast Fourier transformer, on the right is based upon what's displayed here on the left. So when I do things, I can always return to where I was and start over. There's my camel. So these humps here are pretty common in VFD applications. Now, I can sit here, and in the class next week, we'll talk about how to calculate some of these frequencies, but I'm lazy, so let's see if I have static eccentricity. Nope. Let's see if any of these are power harmonics. If I have power harmonic peaks, those don't count. Dynamic, meaning an orbiting rotor. Nope. Stator mechanical issues, basically this means do I have a winding issue and so on. Interturn short, and that's the one we'll talk about later. If I don't have a well-tuned drive, I will get peaks. Okay, not seeing them. Considering I don't have a well-tuned drive, it's pretty cool that I don't. But a lot of the defaults, and then of course my bearing stuff. So I come back down here and look to see if I have bearing peaks that were not detected automatically. I like to go in and verify, especially if I'm hunting for a different type of problem. You see, if I come up here, this would be outer race, this would be inner race, this would be oh, that's the other bearing. Okay, so those are the balls, and so on. So let's come back here to low frequency data, and that one looks ugly. Let's go ahead and just real quick, we'll take a look at a report. This is basically it. It's straightforward stuff. The nice thing is too, whatever shows up on here is going to show up on the report. It does the report in Word. And I'll show you one more thing I do before we end today. You will get a copy of this recording. I'm testing out certificates, so you should even get a certificate tomorrow. Let me see while we're waiting. Okay, oh, we got 53 people. And tomorrow we'll also take a look, or I mean Friday, I should say. Okay, so option. Actually, this is, okay. There are questions, sorry. Let me see if I can see what these questions look like while we're waiting on this. Okay. Okay. The question about beta version. Yes, I'm working with the latest version of the software before we release it this weekend. The full release does all this stuff. All this stuff. This has to do with wind-related stuff for standard machines. This has been there. This is actually the oldest system on the market. The EMPATH system's been out since the early 1990s and was based on the system that was developed before. It is very accurate in finding rotor bars and stator slots automatically. Somebody asked me something about option. Oh yeah, it's what it does is it looks for peaks that are related to the running speed and makes sense. Yeah. Is this system capable of sending out alarm notifications on faults? The EMCS, the ECMS, I'm sorry, the continuous monitoring system it'll send text or email. And I think that is about, yes, that one will. I'm not sure why. These are things I'm going to have to figure out here with this system. Okay, so yes, for all that stuff. And here is the report. Hopefully everything's working all right. We're testing a booster as well for the Wi-Fi here, and the weather outside is nasty if you're hearing strange things. So yeah, this is version 7.1 beta. The beta has to do, it's actually 7.3 beta. 7.3, there were certain things I asked for because general industry doesn't comprehend how to test a wind turbine, especially doubly fed induction generators. That is set up specifically to allow ease of use there because this is quite popular in the wind market. Oh, okay, Bronca's telling me to get closer to the microphone. So in any case, this here is the standard report. What's nice, it's in Word. So what I often do, just to get things to stand out, just so you're aware, if you ever see a report from me, I'll put that up there. And there's an area in the back for summary and so on, but I tend to like adding my own flavor right up front so people aren't hunting for it. That's it. So from here, I can save it. I can turn it into whatever I want, make it part of a larger package. Pretty straightforward stuff. Don't save. And that's about it. So let me check and see if there's any more additional questions. If not, we will end on that. Oh. The older EMPATH software suggests that a load of at least 25% is required. It defaults to that. I asked for them to eliminate that because I had already for years both with this and the at-pole, been testing motors in repair shops as part of commissioning or inspection or quality assurance. Never had a problem. The resolution is just that good. So haven't had an issue with that. Yes, we can absolutely do DC motors. To answer that question, do it quite a bit. I will probably do that as a seminar next week, so watch for that. Now, again, after this one, I will not be doing, this is kind of semi-commercial, probably a little more than semi-commercial. The next ones I do, we'll be using this system, but we'll look at DC motors. We're going to look at different other things. Some of them I'm going to keep proprietary to those industries, but things like DC motor testing and so on. And actually, you brought that up. I didn't have my DC current clamp out on the table, but yes, could definitely do DC, and it does an awful lot of automated analysis. Actually, don't know if it'll work on virtual windows. I'll have to ask. I don't see why not. It actually operates on its own. So when it's installed in the folder, it operates off that. It does not operate off of any Windows DLL. Everybody learned their lessons from that before. And I think I've covered all the questions. So with that, we're going to go ahead and end now. So if there are any further questions, please feel free to contact me directly at howard@motordoc.com or info@motordoc.com, or reach out to me on any of the social media stuff. I'm doing a lot of reports right now. I'm out off the office here and there on Tuesdays through Thursdays for field work, but the rest of the time I'm usually sitting at a computer, gaining weight. So thank you for attending, and have a great day, and you will see this video tomorrow along with the certificate. Thank you.